Good morning, guys. We are going to continue with graphing quadratics. And we're going to be graphing quadratics that are in vertex form today. So it's section 8.4, which is graphing quadratics in vertex form. And right here you can see that's vertex form right there. We're not going to worry so much about what's called even and odd functions. So we don't have to worry about that. It is part of the book, but we're going to not focus so much on that. What we are going to focus on is how to graph in vertex form. So we've graphed in standard form before, and now we're going to graph in another type of form, which is called vertex form. So as you can see, vertex form is shown right here. It's a, and then in parentheses, x minus h squared. Okay? And if we look about learning about what that h is doing here, so when h is greater than 0, it is a horizontal translation. So remember when we were dealing with ax squared plus bx plus c was moving up and down. When we see it in this form, that h value is going to be moving your quadratic function in a horizontal manner, either to the left or to the right. And similar when we saw like absolute value, you'll notice when it's a minus h here, when it's minus here, and we have our h value is greater than 0, it's going to move to the right. And when you see something like a and then x plus a value h, that's going to move it to the left, okay? Key other things that are in here, right here. Okay, the vertex is h comma 0, and the axis of symmetry is x equal to h. All right, so you're getting your you're getting your vertex from right there. So if we look here, it says graph g of x equals 1/2 times x minus 4 squared. Compare the graph to f of x equals x squared. So we know that this minus 4 right here is going to move our graph to the right 4 units. So we know that our vertex is going to be at the point 4 comma 0. So we know our vertex is going to be at this point right here. Now, I'm going to do it in blue, actually, so it's a different color than our parent function. Now, I also know what this 1/2 does from our other sections from before. So that's an a value that's 1/2, which means that it's going to be wider than our original function. So when it's wider, we know that it's going to be called a vertical shrink. Meaning it's being compressed down. So it's a vertical shrink by a factor of 1/2. Factor in there. Now, that's not really helping my cause so much because I still don't know what the actual points are that are a part of this. So it's a good idea when you see something like this to make a table. And always start in the middle of your table with your vertex point. So we know we have 4, 0 as my vertex. So I'm going to use 2 points on either side as my other 2 points. And now to get these points, I'm just going to plug in my x values into my equation. So for example, to get the value of 2, or let's do 3 rather, I'm going to do 1/2 times 3 minus 4 squared, and that's what y is equal to. So all I've done is I plugged in that x value of 3 right there. So 1 squared is 1. 1/2 of 1 is 1/2, so I know my value is going to be 1/2. So I know that this is 1/2, and this is 1/2. So I'm going to plot those points there. So there's 1/2 and 1/2. And then do the same thing and plug in 2 into your equation, or 6 in. 6 minus 4 squared is 2. 2 squared is 4. Half of that is 2. So I know I'll have values at 6 comma 2. And then at 3 comma 2. Or sorry. At 2 comma 2 as well. Now, one other thing, I know my axis of symmetry goes through the vertex, so I know that my axis of symmetry here is an equation of a line, and it's going to be x equals 4. So it's that dotted line that goes there. And let's draw in our line now. Oops. So if we draw in that line, or that parabola, I should say, it's not a line, that's what I'll end up getting. And again, you could use Desmos to help you do this, but it's important that you're able to describe what's happening like we did here. Here is the Desmos version. It's a nicer version of what I just did. Here are some more examples. One thing I'll just note, we'll go through number 5, is that here you have a flip, right? So it's a reflection. So let's start by doing our vertex. Our vertex is going to be at 2, 0 here. I just want to make note here on this one, number 4, that your vertex would be -5, 0. So it kind of takes on the opposite side as what you would think. So our vertex here is going to be 2, 0. I know my axis of symmetry, my AOS is going to be at x equals 2. So here's that. And let's draw in our axis of symmetry going through there. Again, probably a good idea to make a table. X, Y, and at the middle of your table should always be your vertex. So there's 2, 0, and then I'll also do 3 and 4, and 1 and 0. If I plug 3 in, 3 minus 2 is 1, 1 squared is 1, and then make it negative. So it's going to be a -1, and this will be a -1, so I know I'll have points here and here. Plug in 4, 4 minus 2 squared is 2. Make it negative, so -4 and -4. And then those are my other 2 points. So here is my parabola. Keep in mind here, this would be a reflection. There's no shrink or stretch though, okay? Because I didn't change that A value that's out in front. So now we're adding one additional part in here. We're adding a K as well. So if you notice here, when we have it in vertex form and we're adding that K value in, now we're going to be dealing with both a horizontal translation and a vertical translation. Key part down in here, okay? The vertex of the graph is going to be h comma k. So h comma k is your vertex, and then your axis of symmetry is still at x equals h. And again, you'll be making tables as you go through this. So let's take a look here. We want to graph -2 times x plus 2 squared plus 3. So a couple things here. First of all, we know where we're going to be getting our vertex from these 2 points, but we know that the x value of the vertex is the opposite sign that we see. So our vertex here is going to be at the point -2, 3. Our axis of symmetry is going to be at x equals -2. So I know I have a vertex at -2, 3, which is right there. And I'm going to have to get some other points. Now I know it's going to be a reflection, meaning it's going to flip. And I know that this is going to make it narrower, so I know it's going to be a vertical stretch by a factor of 2. I'm going to make my table this way, just because I'm running out of room. Now, always start with the vertex in the middle, so -2, 3. And then I'll pick points that are on either side of the vertex. So I'll pick x values of -3, and then -1 and 0. And now I'm just plugging into my formula. So I'm plugging in those x values to get the y values. So when I plug in -3 into my equation here, -3 plus 2 is -1. Then I have to square that. I'll get 1. -2 times 1 is going to be -2 plus 3. This will get me a value of 1. And then I know I'll have a 1 over there as well. So if I continue to make my points, I know I have a point at -3, 1, and then at -1, 1. And then I can plug in either 0 or -4 into my equation. If I plug in 0, 0 plus 2 is 2, 2 squared is 4, -2 times 4 is -8, and then add the 3, and I should get an answer of -5 here. So my next point, 1, 2, 3, 4, will be down here. And here. And you'll see this is my graph. All right. And there's the Desmos version. Same thing. Make sure, though, guys, you can explain what's going on here. That's the key part.